All right, welcome back to Live Unit Programming. Today we're going to move on to a little bit more C++ programming and work a little bit with actors and how tick functions work and stuff. But before I do that, there's two things that I want to go over. One is I've put everything up on GitHub, and I'm going to show you a little bit about where to find that and how it works, and I'll leave a link in the description of the video so that you can pull the code from GitHub. So this is my GitHub site, and it's here at Westlake UE4 4.27.2 C tutorial. That was supposed to be CPP tutorial. I must have made a mistake there. That's okay. Well, it's called the C tutorial now. That'll probably drive some C pundits up the wall because I'm doing C++. But anyway, if you go here, you will find this pull down here for the different branches. The main branch will always have the most up-to-date code. And when the video series is complete, it'll have the completed code. But each branch here will contain the code at the end of that particular video, what its state was. And you'll be able to switch to those and pull down the code that completed at the end of that tutorial, which is the start of the next video. So either way, if you want to do it, you working with code starting a particular video, pull the code from the previous video. So that's been covered. The next thing I want to cover is just a little bit about where I'm going with this game system and what I would like to do. And I'm going to show that and explain that right now. So what I want to approach in this course on C++ is a gaming style similar to Minecraft. Minecraft uses voxels where you can place blocks adjacent to each other, on top of each other, and you can connect them together. It also has automation components that's called redstone. Well, we're going to do something similar, but we're going to not use redstone, of course. We'll use a different mechanism. In fact, what I want to use is wires and pipes and stuff. You know, there can be power cables, there can be signal cables, there can be pipes for carrying different kinds of liquids around, and we're going to work through all of that and build up the necessary classes in C++ to handle all that. To do that, we need kind of an update system that's going to move information along through these voxels. Also, I don't want an entire world of voxels like what we see in Minecraft. I want a smooth world like we have traditionally done in Unreal Engine, but the ability to build with voxels. And the way we're going to do that is by setting down some kind of cornerstone. And this cornerstone will be the piece that lays out the grid for all the building off of that cornerstone. And everything you build then with voxels will have to be attached to that cornerstone or through other blocks to that cornerstone. And then you can, of course, make multiple cornerstones. And there's a there's a little automation for you blowing stuff up with TNT in Minecraft. So to do that, we're going to have to set up some mechanisms for these blocks to not only align with each other properly within the grid that we establish, but communicate with each other and send signals and so forth back and forth. So that's what we'll be working towards in building up these various components in Unreal. Okay, so now that you have an idea of where we're going with this, let's take a look at Unreal Engine. And let's go ahead and create a new class. And we're going to go to Show All Classes, and I'm going to look up here Static Mesh Actor. And I'm choosing a static mesh actor because it already has a static mesh component. And we don't have to add that, and I can show you a little bit about that stuff. But what we're going to be doing is working with the tick, and all of our actors in this realm are going to be some kind of static mesh associated with them. They may have other things going on too, and that static mesh may actually be movable, and we'll show you how that happens as well. So we click next, and I'm going to give this a name, and I'm going to call this Tick Manager, and I'm going to append actor onto the end of it so that it's a Tick Manager actor, and we will create that class. And hopefully this doesn't take too long. Okay, so our class is generated, and it's open over here. We'll just change screens. There we go. So this is our Tick Manager Actor class. Okay, and it's based on a static mesh actor. A static mesh actor base class has a static mesh component to it. We've seen those working with blueprints. It's just a place where you can drop in a static mesh and manipulate it with the code, and we can call upon that from here. But we're not going to do that in this base class. We're just going to work with the tick function. So, what do we need? First of all, we need a couple of things. We need a tick function, and I'll just copy paste this in and then explain it. So this is how we declare our tick function. It's virtual void and it's override, and it's override because a static mesh actor is based on actor, which has these classes have this virtual tick function that gets called by the system. So we're overriding it so that we can gain access to it here. We also are going to create our own virtual method for our class. Virtual void controlled tick. This controlled tick function is one that we're going to call in order to fire our tick events. And then we need a couple of properties. And I'll just paste these in here, and then we'll go work on the code. So again, this is a U property. It's edit anywhere, which means that it can be edited in the editor by the designer. When they use this class to build up, say, a blueprint class of their own based on this to do some game functions, they'll be able to modify this tick time. Now, what is the tick time? I've set it default 0.1. This is in seconds. In fact, I'll make a note of that here. It's a floating point number in seconds, and it specifies how often this will produce this controlled tick event, which is a U function, and it has this special property here. In fact, I should put this under a category. Now let's make this a category equals events. It's blueprint implementable event, which means that we're not going to put any implementation in this. We're just going to create an empty function body. And what happens is in the blueprint, you can create an event off of this, and blueprint will receive that event. In other words, this is how we call blueprint code from our C++ code. And finally, we're just going to create a private value here, an elapsed time. This floating point value is going to be controlled by the tick function. It's going to add up the time elapsed across these ticks, and when it reaches this tick time, it's going to fire this controlled tick virtual method, which will allow us to override this in other classes to possibly do other things. And the controlled tick method by default will call this controlled tick event, and then it will reset this elapsed time back to 0. And so I'm going to also initialize this to 0.0f. Okay, so far so good. Let's take a look at the code. So in the code, uh, hold on, did I? One second, let me look at some things. Oh, yeah. So also, we need one other thing. Uh, we need a we need a constructor, and this is going to be a tick manager actor, just like that. So let's get this and go over to our code, and let's do this first. Colon colon. And what we want to do in this function is we want to be able to tick. So we're going to call primary actor tick dot b can ever tick equals true. So this just makes this so that it can be true, so that it can tick. We're going to do something else with this as well in the future. We're going to add something to this, but I'm not going to get into that right now. It has to do with replication and working with servers. So I'm going to put a note here also. Replication. We need to tell this thing that it can replicate, because we will be using this in a server environment in the future. But we won't initialize that just yet. So we've got it turned on so that it can tick. This is in the constructor, so when this gets constructed, it will know how to tick. We don't actually need to call begin play in this, or we don't need to deal with begin play in this, but we could. So what we need is our tick function next. So let's get this tick function. We don't need the override. Let's copy it, paste it into here. We'll get this, paste it here. So here's our tick function, and I'm going to lay these out. We also need our controlled tick event. And our controlled tick. So let's just go ahead and put those in. Void controlled tick float delta time, and then we have a void controlled tick event float delta time. All right, so now what are we going to do with these? So the first thing we're going to look at here is tick, and we're going to call super tick with delta time. This is very important because we want whatever's going on in the super class, the base class of all this, to also receive its tick properly. So we need to call that. The next thing we're going to do is take this elapsed time value that we set up, and we're going to add to it the delta time. That is the time that is elapsed since the actual last tick. This is the time that's elapsed since the last system tick that came. Okay, so every tick gets this delta time as a floating point value so that the game knows how much time has actually gone by in case there's some lag or the ticks slow down a little bit, the frame rate slows down. We know the actual time since the last one. And then we're going to say if elapsed time is greater than or equal to tick time, which is that settable value that we created, then we're going to execute this body here. And what we're going to do is we're going to call this function controlled tick with delta time. And then we're going to set elapsed time equals 0.0f. And then all we're going to do in controlled tick is call controlled tick event. So we're going to call controlled tick event with delta time. And that's all we have to worry about. And we don't have to put anything here. This will be implemented in Blueprint. All right. Well, let's check it over and make sure I didn't make any stupid mistakes like unfunction or anything like that. I don't think I did. This all looks good. This looks good. So let's go ahead and switch back over to, I think it's all saved. Switch back over to here and try to compile it and see what kind of errors we get. The compiler is the best way to find errors. Let me tell you, you can stare at code all day long and not see an error. The compiler will find it very quickly. Yeah, and it sure did. Let's show the log. What do we got here? Log compiler, a private function. What does this say? A private function cannot be a Blueprint implementable event. Oh, yeah. Okay. I did miss something here. Everything, all of this needs to be public. Okay. Let's try one more time. Maybe we'll get lucky and that's the only error. And it's compiling. And compile failed again. Of course it did. Tick manager actor error. Already in tick manager actor. What? Oh. Sorry. I don't think we need to implement this at all. I think I noticed that once before. And forgot to take it out of my notes. There, compile complete. Yeah, so when you do this, a Blueprint implementable event, you just declare it up here. There's no need to write any code for it here. It'll be implemented in Blueprint if Blueprint wants to use it. Otherwise, it's just stubbed out by the system so that nothing happens when this calls it, which it will do periodically. So we now have our class with its controlled ticks. Let's go back over to... oh, we're in the code. Okay, let's go. Let's stay right here, and let's go back into our. No, we don't want to go into the level blueprint. Well, we could just draw. This is a static mesh actor. We could just drop it in the scene. But actually, you know what? I'm going to delete that. And I'm going to create a blueprint from it. Create a blueprint class based on tick manager actor. Or we can go in here. Let's do it this way. Let's go here. Let's create a new folder. We'll just call it actors for now. We'll probably organize this a little different later on, but we'll go in here and create a new blueprint class. We don't want it based on this. We want to look at all classes, and we want to search for tick manager actor. That's the one we want. Select that, and we'll call this tick manager manager underscore BP. And we'll open up this blueprint. And we'll go here to the event graph. And here we have the normal event tick and all that. Let's see if we go down here to events. There should be an events list. There is not. I thought I put it under events. Let's try controlled tick event. There's our controlled tick event. If we look at set that's interesting. I think I might have found a feature of Unreal Engine that I didn't know about. But anyway, this is example code, and we might change this to take advantage of some stuff that's already in the engine. But this is example code, just to show you the kinds of things that you can do. We've got our event coming out here and our delta time. Let's go in here and do a format text, and we'll do a simple format of 0, dash 1, and there's our 0 and a 1. We will do a print string, run this into here. We'll put our delta time into this, and what else do we want to do? Let's call on our function. Let's call on our random eyes dice roll. Let's plug this into here, bring this over here, make this a little more readable. We'll plug this into this value here. So we'll get the time and the tick, and we'll plug this into here. It'll convert it. And let's set this to 6 and this to 2. Oops, not 21. I want 2. And compile it. Save it. Let's go back to here and hit save all. Just in case things go bust. Sometimes they do. And they're coming out, but they're coming out fairly fast. So let's change that. Let's change a couple things. Let's go into here, pull this down, and change this duration to 10 seconds. And let's go, we'll compile and save that. And let's go back to here and go to our we never put it in the scene, for one thing. And then here under settings, let's change this to 1 second. And we'll just hit save all. Okay. Okay. Well, there was absolutely nothing wrong with the code at all. If you recall from the previous video, I went into the level blueprint and I put some stuff in here to print it out. That's what we were seeing coming out was my code from the previous video here in the level blueprint, not the code from this new setup here. So now if we hit play, you'll see once a second this is coming out. This is set to, oops, I just hit the button and fired the gun. This is set to 1 second. If we set this to like 0.2 and hit play, it comes out a little quicker, but it's not screaming out as the tick rate. So it's following. You can see here from the delta time, it's coming out pretty close to 0.2 seconds for each one of those. So this is a way that we can control the tick rate on a class by class basis, on a system by system basis as we put things together. And as you saw from the Redstone video I showed you, or not the Redstone, but the Minecraft video I showed you at the beginning of this, there's different update speeds. Redstone updates in Minecraft at a different rate. Well, we're going to have to be concerned about that because that's all about server loading. If you put a lot of stuff together in a game like this where you're building things that can communicate that way, you want to keep the update rates under control, and we're going to have some very special strategies for how we go about that. So anyway, that's it for this video. We covered the idea of creating an actor, and here it is. I went and added a static mesh to this actor. If you just go to the actor blueprint, the static mesh, here it is. I just made it a 1 meter cube. And shows that it is in fact our tick manager class is in fact a static mesh actor. We can add a static mesh to it and move it around, place it where we want. So and this 1 meter cube here probably looks a little bit familiar. We might just have we might just have a bunch of these going on with different textures on them being our building blocks. If we go in here into play mode, you'll see that we can go up here. And unlike the other blocks around here, this is mobile. So this over there, for instance, they'll be knocked around. They've got some physics. And we're going to do that in an upcoming video. We're going to make these things placeable, movable, breakable, and possibly even stuff that can be knocked around like these blocks over here. So anyway, that's it for this video. Thanks for watching. I hope you liked it. If you really liked it, hit that like button. If you really liked it, hit that subscribe button. And hopefully you'll hit those notifies too and get notified when I put up some new videos. So also check me out on Twitch. I'm streaming Minecraft videos from on Twitch on Sundays, 12 to 2 U.S. Eastern Standard Time. So if you're interested in watching those videos and seeing me build up my base and work on stuff, come on out and say hello. Thanks for watching, and I'll see you in the next video. Bye now.